Every time you touch your phone, something invisible happens under the glass. It feels like the screen simply knows where your finger is, but it is not guessing, and it is not waiting for you to press hard. Modern touchscreens are not really detecting pressure. They are detecting tiny changes in electricity. Under the smooth glass is a hidden transparent grid. You cannot see it, but it is always active, always watching for a change. When your finger gets close, it becomes part of that invisible electric system. The screen senses a disturbance exactly where you touched. That tiny disturbance becomes a location, a coordinate, a command. And in a fraction of a second, your phone turns one simple tap into an action. The secret is something called capacitance. Your body can hold and affect electric charge, even in very small amounts. The screen creates a weak electric field across its surface. When your finger touches the glass, it changes that field. The phone measures where the change happened. It looks at the invisible grid beneath the screen and asks, which lines changed? Which point was disturbed the most? Where do the horizontal and vertical signals meet? That meeting point becomes your touch location. It is like the screen creates a hidden map and your finger drops a pin on it. Then a controller chip reads that point and sends the information to the phone's processor. That is how a tap becomes an app opening, a button pressing, or a photo moving. A tap is only the simplest version of the story. When you swipe, the phone is not seeing one long motion. It is tracking many tiny touch points, one after another, so quickly that your brain sees one smooth movement. When you pinch to zoom, the screen tracks 2 points at the same time. It measures how far apart they move, then changes the image to match. With multi-touch, it can follow several fingers at once. But this also explains something strange. Regular gloves often do not work because they block the electrical connection between your finger and the screen. A touchscreen glove works because it has conductive material inside the fabric. That material carries the electric effect from your finger to the glass.
Water can confuse a touchscreen because water can also affect the electric field. That is why a wet screen may tap things by itself, ignore your finger, or jump around unpredictably. The phone sees electrical disturbances, but it has to decide which ones are real touches. This is where the touchscreen controller becomes important. It constantly scans the grid, filters noise, and checks the shape of each signal. A fingertip creates a different pattern than a water droplet. A palm creates a much larger pattern than a finger. That is how tablets can reject accidental palm touches while still following a stylus or fingertip. The device is not just detecting touch, it is interpreting touch. A stylus can be even more precise because its tip creates a smaller and cleaner contact point. Some advanced styluses also send extra information, like pressure, tilt, or button input. That is why a digital brushstroke can become thicker when you press harder. But for normal finger touch, the screen does not need to read your fingerprint. It does not care who you are. It only cares where the electrical change happened. Even if your finger is wide, the phone can estimate the center of the contact area. That center becomes the coordinate it uses. Small fingers, large fingers, quick taps, slow swipes. The same hidden system turns them all into precise digital instructions. The touch screen is as invisible map made of thousands of tiny sensors. Every time you touch it, a part of the map lights up. The phone finds the strongest signal, calculates the position, and responds almost instantly. But the system can fail if the hidden grid is damaged. A cracked screen may still show images, but the touch layer underneath can be broken. That is why some screens develop dead zones or ghost touches after being dropped. Screen protectors usually work because the electric field can still pass through the extra glass. But if the protector is too thick, low quality, or not attached properly, it can reduce sensitivity. The screen is always trying to feel tiny electrical changes through every layer above it. So, the next time you tap your phone, remember what is really happening. Your finger is not pressing a button. It is disturbing an invisible electrical field. A hidden grid finds the exact point. A tiny chip calculates the location, and the phone turns that signal into action. Every tap has a hidden journey, from skin to glass to electricity to code. And it all happens so fast that it feels like magic. But now you know the trick. Your touchscreen is not just glass. It is an invisible electrical conversation between your body and your phone.